All right, gang. 55 Math 5500. Sorry for the abrupt ending of the previous video. I got had a distraction and had to go quickly. But anyway, I'm just going to start off where we were. So we look at the determinant. We're looking again. We're examining this X transpose X matrix, and ultimately, I'm going to be uh, transitioning into the inverse of this. But anyway, we saw previously that this is a 2 by 2 matrix that has this form, and we know the determinant again is taking the products minus the product of the other diagonal. All right, so we can build up on this just a little bit. If I factor out the n, I know that I have the sum of the x sub I squared minus 1 over n times the sum of the x sub i's quantity squared. Now, this will actually collapse to, or simplify to, n times the sum of the deviations squared for x. Kind of cool stuff. You should, yeah, it shows up a lot, this sum of the deviations for x squared. And you should verify this. I'm not going to because, again, I want to I want to get to the other stuff as quickly as possible. I guess. Uh, so, and it's a very 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 simple proof, not difficult at all. So now we can say that given A, that A inverse can be found by, and I always remember this like this from way back, that I remember I start here with the A term, and I go up here and it's the opposite term, and I come down here and it's the opposite term, and then I have D over D. And again, think about A being in the form A, B, C, D. So the inverse can be found this way. Kind of a cool result. And it's really cool because it it helps us here, right? So again, given that x transpose x is in some x, some x, some x squared, uh, and our determinant is equal to n times the sum of the deviations for x, we see that x transpose inverse is equal to, again, here we have our d, which is in that location, so the sum of the x sub I squared over, I'm not going to write out the determinant, so I'm just going to put a d, so this is just going to be d in this illustration. Next I have, CAB, so negative, I should have written this out, not that clever. N over D. Now this simplifies to something that we also see a lot, so this is just 1 over n plus the grand mean squared over the sum of the deviations squared. This part is just minus the grand mean over the sum of the deviations. As you would expect, this is the same as that. It seems like that's an emerging theme, right? And this, let me step back and make sure I got that right. Something doesn't seem fit right about that. Yeah, that's right. So yeah, okay. So that's a way that we can calculate the inverse of x transpose x. All right. that should have been in one video, but again, I got distracted by something that was out of my control. So it's just two short videos. So take care.